Hi there, in this video we're going to learn about the binomial theorem and Pascal's triangle and how it relates to the binomial theorem. So what is this? So the binomial theorem is a shortcut formula that is used to help us expand a binomial expression raised to a power. So that's kind of a lot, so I'd like to kind of break this down. So a binomial is if you have two terms added or subtracted together, raised to some power. And you've seen this before when you've done the perfect square trinomial or the difference of squares or the difference of cubes or the sum of cubes. You've seen this before where you're actually multiplying this out. So something like if it was x plus 2 squared, where you used FOIL, okay? But now we're taking this exponent and we're making it a lot bigger. And so instead of just multiplying this out 2 times or 3 times, we're going to have to multiply it out 5 times or 7 times. That's a lot of work. So we're going to use this binomial theorem to help us alleviate some of that repetition that we have to do when we're multiplying. We're constantly distributing. So they came up with this formula. And actually, I'm just going to get rid of this calculator for a second. So here's the formula. And when you look at it, this is my first reaction to the formula too, is, what does all this even mean? So basically, this is a coefficient, which is a number that's out in front. All of these. And then it's giving you a pattern of your exponents. So your exponents, your first term, this square right here, has the exponent that's the same that you're raising at the power 2. And it decreases by 1 every time until it gets down to 0. The second term, the exponent starts at 0 and increases by 1 every time until it gets to the exponent that you're raising your initial power to. This NCR stands for combination, which we will talk about, or I will talk about more in depth in a later video, but this is how we find the coefficient, the number that goes out in front in each one of these terms. But we also have another way that we can do that, which is called Pascal's Triangle. And I'll talk about that in a minute. So I just wanted to kind of give you a breakdown with some examples. So there's basically 2 things that are happening here. The first thing that the binomial formula tells us is that we're going to take this exponent here, and it tells us how to split it up. So if we're raising something to the 4th power, we're going to have 5 terms. And we're going to just count down. So can you count down and can you count up? That's the first thing that you want to know. So I'm going to write out all my terms, whatever my terms happen to be. So in this one, it happens to just be x and y. So my x is going to start off with a power. Actually, I'm going to make this blue so it matches. To the 4th power, the power that I start off here. And then I'm going to count down 4, 3, 2, 1, 0. Now I'm going to count up with my y value. I'm going to start at 0 and go 0, 1, 2, 3, 4. That gives you the exponents. Okay. The next thing that we have to do is look at the coefficients, okay, that go in front. So we're looking for what are these numbers here, 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 and here. Okay, so we talked about combinations. It's kind of a little bit of a confusing way to do it. I like to use this way better. It's called Pascal's Triangle. It's invented by a guy called, last name Pascal, who found this relationship between the combinations of numbers. So here's how Pascal's Triangle works. It always starts with 3 ones on the top. To get the next number, to get the next row, so if I'm looking here, we know that our row always starts with a 1 and ends with a 1. And to get the number in between, you add these 2 numbers together. So 1 plus 1 is equal to 2. Okay, again, I start with a 1 and end with a 1. So, and to get the numbers in between, I add these 2 numbers. 2 plus 1 is equal to 3. 2 plus 1 is equal to 3. Again, start with a 1, end with a 1. So I add these to get the numbers. 1 plus 3 is equal to 4. 3 plus 3 is equal to 6. 3 plus 1 is equal to 4. Start with a 1, end with a 1. Add together the numbers. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4, 4 is 10. 4 plus 1 is 5. Start with a 1, end with a 1. Add together to get the numbers. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Let's see if you can make the next 2 rows. Now's a good time to pause the video and see if you can do it. So, start with a 1, end with a 1. 1 plus 6 is 7. 7 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. Start with a 1, end with a 1. 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 35 is 70. 35 plus 21 is 56. 21 plus 7 is 28. 1 plus 7 is 8. Now that you understand the pattern, I found one for you that's, I can't write that small, so I found one that goes all the way up to row 16. So here's what you need to understand. If I go back up here and I'm looking at the coefficients, I want to look in row 4 because I'm raising it to the 4th power. How do I know which one row 4 is? Well, first of all, it starts in row 0, but I don't even remember that. I look here and see whatever number comes second, that's what exponent I'm raising it to. So my exponents in this case would be 1, 4, 6, 4, 1. So this would be 1, 4, 6, 4, and 1. And I'm going to throw an addition sign in between each of my terms. And now I've just expanded x plus y to the 4th power. So you might ask though, how does this even work? So remember when we would multiply this out, if we used the long way, if we used FOIL. Okay, so we go first, x times x is x squared, outer, x times y is xy, inner, y times x is also xy, and y times y is y squared. These are my like terms, I can combine them together. So I ultimately end up with x squared plus 2xy plus y squared. And if you look at the binomial formula, 2, 1, and then here, x is to the 0 power because it's not, because this is x to the 0 power, because anything to the 0 power is 1. So then you can look at it this way. This would be y to the 0, y to the 1, y to the 2. So this trick expanded using the binomial formula, and then you can also pay attention and see, well, this is a 1, this is a 2, and this number right in front here is a 1. So if we go all the way up to our row number 2, our coefficients are 1, 2, 1. So that's how the binomial theorem works with Pascal's triangle. Okay, so like again, if I use the shortcut, I would go xy, oops, I'm going to leave some space, xy, xy, I would go 2, 1, 0, 0, 1, 2, and throw in my coefficients, 1, 2, 1, with a plus in front of each one, which simplifies up to here, which is what we just had. And you can leave your answer like this, or you can simplify it to give you this. Either way, you get the same thing. So that's how come it works. That's why it works. And that's why we have to have these coefficients here, because we do end up with like terms, and it tells us how many like terms we have of each kind. Okay. So if I wanted to expand x plus y to the 5th, this is technically an example. Okay, I would first do my variables or my exponents. So I would say this is 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5. Oh, and something to note that I forgot to point out. See all of these add up to 5? 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. And 5 plus 0, 0 plus 5 is 5. So that's something also to note. Okay, so I did my exponents. Now I'm going to use Pascal's triangle. I'm going to come up here, find my 5th row. This is my 5th row. 1, 5, 10, 10, 5, 1. So I come down here and we'll do green. 1, 5, 10, 10, 5, 1. And there you have it, folks. I just expanded that using the binomial formula and Pascal's triangle. Now, things get a little bit trickier when you have a coefficient in one of your terms. So we're going to do this the same way. The concept remains the same. So I'm raising it to the third power, so I know I'm going to have 4 terms. So I'm going to say this is x and 3y. I have x and 3y, x and 3y, x and 3y. And I have my exponent, so this is going to be 3, 2, 1, 0, 0, 1, 2, 3. And raising it to the third power, if I come up here to Pascal's triangle, my third row is going to be right here. It's 1, 3, 3, 1. So I come down here, I have a 1 and a 3 and a 3 and a 1. Now I want to expand this all the way, so I'm going to do this kind of one term at a time. I'm going to throw a plus in front of each one of these guys, and I'm going to expand. So this first one, I'm going to just stick with orange. So anything to the 0 power is 1. 1 times anything is itself, so this term just becomes x to the third. Okay, next. Okay, so I have a 3 times an x squared, and 3 to the y, 3y to the first power is just 3y, but then I have to multiply these numbers together. So 3 times 3 is actually 9, so this second term is 9x squared y. And I'm going to bring down this first term. Okay. Next, all right, I have this 3 stays, x to the first is x, 3y squared is going to be, I have to square each one, so 3 squared is 9, and y squared is y squared, and then I'm going to multiply my numbers. 3 times 9 is 27x y squared. And then last but not least, I come over here. So I have this one, anything to the 0 power is 1, which goes away, and then 3y squared, 3y to the third power, it gives me 27y to the third. So this is 27y to the third. So my final answer is going to be x to the third plus 9x squared y plus 27xy squared plus 27y to the third. Now you'll see the interesting part is see how our coefficients were 1, 3, 3, 1. In my final answer, those are not my coefficients because I had this other number right here in one of my binomials, so it changes what the coefficients are in front. So watch out for that. Okay, if we did another one, now I put a coefficient in front of each term in the binomial, and we're going to pay attention to that this is a subtraction, so I want you to see how this changes it. So because I'm raising it to the 4th power, I'm going to have 5 groups. So I'm going to write this out. So I have 2p, negative 5q, 2p, negative 5q, 2p, negative 5q, 2p, negative 5q, 1, 2, 3, 4, 2p, negative 5q. I'm going to shrink these down just a little bit so I have space for all of it. Whoops, let me try that one more time, sorry. And move this guy. And maybe move a couple of these. So I have a little space. Okay, so I'm going to start with my exponents. I got 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. And my coefficients. So I'm going to go to my Pascal's triangle. I'm going to look for row 4. So in row 4, I am right here. I'm at 1, 4, 6, 4, 1. So I'm at 1, 4, 6, 4, 1. Okay, and I'm going to throw a plus in front of each term. And now I'm going to simplify. Okay, we're going to do one at a time. Okay, we'll start with, I'm going to write with the color blue. Okay, anything to the 0 power is 1, so this goes away. 2p to the 4th. So I have a 1 out in front. 2 to the 4th is 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16. So this becomes 16p to the 4th. So ultimately this is 16p to the 4th. Okay, next. Here I have, okay, I have a 4, 2p to the 3rd. 2 to the 3rd is 8, so this would be p to the 3rd, and then I have a negative 5q. So I have to multiply all of those together. So I end up with 4 times 8 times negative 5 is going to give me negative 160 p to the 3rd q. Okay, next. Here I have a 6. 2p squared, so this is going to give me a 4p squared, and negative 5q squared is going to give me a positive 25q squared. So I multiply all this together. 6 times 4 times 25 gives me 600. So I'm at 600 p squared q squared. I come over here, I have a 4 times 2p, and negative 5q to the 3rd power is negative 125q to the 3rd. So this becomes 8 times negative 125, gives me negative 1,000 pq to the 3rd. And my last one, I have a 1. Anything to the 0 is also 1. And then negative 5 to the 4th power is going to be 625 q to the 4th. So 625 q to the 4th. Okay, so if I shrink this all down, this becomes, now notice this is subtraction. So this is a positive, this is a minus, this would be a plus, this would be a minus, this would be a plus. Notice in my final answer that my signs are alternating because I have this subtraction here. Okay, now, the other thing that they can ask you is to just find the coefficient of the term in the expansion. So here, I can use Pascal's triangle because I'm to the 11th power. So if I come here, actually, let me do this first. Okay, so this would become t to the 4, s to the 7. So that means this is 2t. To get t to the 4, this one has to be to the 4th power, and negative s has to be to the 7th power. So I have to figure out what number is going to go in front here. And because this is to the 11th power, when I'm using Pascal's triangle and my t comes first, I have to count 11, 10, 9, 8. So I'm going to go up to my Pascal's triangle and I'm going to count till I get to 4. And I'm going to use, whoops, this one here. So I'm at 11, 10, 9, 8, 7, 6, 5, 4. This would give me t to the 4th at 330. So this number would be 330. So what I'm going to do is I have 330 here times 2t to the 4th. Well, 2 to the 4th. 2 times 2 is 4, and 2 times 2 is 4. So 4 times 4 is 16. So this would be 16t to the 4th times negative 1 s to the 7th is going to give me a negative, and then s to the 7th. So I'm going to multiply my numbers together. So I have 330 times 16 times negative 1 is going to give me negative 5,280 t to the 4th, s to the 7th. That would be, so if they just asked you your coefficient, then you would tell them it's negative 5,280. Now what happens when they give you an exponent that's too big for Pascal's? That's when you go and you use that combination. So on my calculator, I'm going to show how you do this. You're going to look for something that's called this NCR button, okay? So I'm going to come over here. On mine, I have to hit function, and I'm looking for this right here. Some calculators, depending on the kind that you have to enter it in different. So this one gives me parentheses, which tells me I have to enter my two numbers. So I'm going to take the first number that I enter is 23 because that's the exponent that they give me here. And then I'm going to hit a comma, and I'm going to choose this number here, 23, and we say this is 23, choose 3. So I come over here and I write 23, comma 3. It tells me that my coefficient would be 1,771. Now, the nice part about it, because in Pascal's Triangle there is a pattern, and you can see that the numbers go up and then they go down exactly the same. Say you forgot and you said NCR and you did 23, choose 20. It gives you, just so you can see it, it is the same number, 23, choose 20, because it is symmetrical. Okay, so even if you forgot. All right, so I would come over here and I would say that my number that comes in front is 1,171. And I take my u to the 20th power. And my second term, which is negative 3p, gets raised to the third power. And I know that because they want my u to the 20th and they want my p to the 3. That's how I know what numbers go there. So now I evaluate. So I have 1,771 times u to the 20, and then negative 3 to the third, negative 3p to the third. So negative 3 to the third is going to give me negative 9 times p to the third. So ultimately I multiply my numbers, 1771 times negative 9 gives me negative 15,939 u to the 20, p to the third. So if they just want the coefficient, then you would give this number negative 15,939. Or sometimes they ask you for the full term, and then you would give the full answer. Okay, so let me know if you have any questions about Pascal's Triangle, about binomial formula, about how to use a calculator to find combinations. Oh, by the way, when you do that, some calculators, they let you choose it in like this. NCR, you would write 23, choose 3. Or 23, choose 20. Some calculators do let you type it in that way, so it just depends on what you have. Let me know if you have any questions. Good luck.